So in this section, we're trying to determine if some given functions are even, odd, or neither. And again, the key is we're always told what f of x equals. What we're asked to do is to figure out if f of the opposite of x, if these two quantities are related at all, if they're the same or they're the opposite. Again, we're always given this, so that's the easy part. When we do it algebraically, we have to calculate this part of it. We're also asked to look at it graphically. So remember, graphically, you look for symmetry either with respect to the y-axis or with respect to the origin. So for the first one, this graph clearly has symmetry with respect to the y-axis, so which means points match up. So if I plug in 4, I get the output 9, and I can see from the graph then if I plug in -4, I'm going to get the output 9 again. So again, when we change the input from between 4 and -4, nothing happens to the output. That makes it an even function. To show that algebraically, again, we're given f of x to be x squared minus 7. Our job is to calculate f of the opposite of x. Okay? But again, this function is just you square the input and then subtract 7. Okay? And we can simplify this a little bit because obviously the negative squared becomes positive. So again, we see that when we put in x or its opposite, we get the equal outputs. And again, that's an even function when f of x equals, f of -x. Next one, again, if we check graphically first, is there symmetry with respect to the y-axis? Clearly not, okay, because it doesn't fold together. The other one, remember, is symmetry with respect to the origin, which is a 180-degree rotation. But in particular, you can see this one spot right here, if you rotated it around, should wind up here in the second quadrant, and there is no graph in the second quadrant, so there's no symmetry. So this should turn out, based on the graph, to be neither even nor odd. Okay, let's check algebraically. So again, we're given the function. That's sort of half the work already done for us. Okay. Our job is to calculate and examine g of the opposite of x. So again, the input has to get cubed minus the input squared. Okay. Clean this up a little bit. Right, cubing the negative, we'll still leave it negative, and then the x is cubed minus, square that negative inside, it becomes positive, and then x squared. Okay. So again, we need to compare these two. What happens when you plug in x? What happens when you plug in -x? Well, they're clearly not the same, so that's not even. But they're also not opposite. Okay, and again, what would the opposite of g of x be? That's the other option. It would be the opposite of x cubed minus x squared, which is -x cubed plus x squared. Okay, that's not what we have. So again, this would mean it's neither. Last couple, again, we could do some symmetry work here. Number 3, the graph is symmetric with respect to the origin. That's a 180-degree rotation, and the graph falls on itself, so we would expect this to be odd. How do you show that algebraically? Again, you're given h of x. Your job is to clean up and calculate what h of -x is, or the opposite of x. So again, it's going to be the input cubed plus 3 times the input. Okay. So cleaning that up a little bit. Again, negative cubed is still negative, and then you have the x cubed, and then plus 3 times -x would be minus 3x. Okay. So again, compare what happens when you plug in x to what happens when you plug in -x. These are clearly not the same. That means not even. Are they opposites of each other? Absolutely. Both signs change. So again, we're checking the opposite of h of x. It's the opposite of x cubed plus 3x, which again is -x cubed minus 3x. So that is what turns out, which is our case here. So remember, these two are not equal, so that meant it was not even. These two are equal, that makes it odd. Okay. When you plug in -x, you get the opposite of what you started with. That's the odd functions. And then finally for number 4, again, by symmetry, it certainly looks like we have this 180-degree rotation, which would make it an odd function. to show it algebraically, again, we have what f of x is. Our job is to consider what f of negative x is. Okay. So again, the input has to get squared, and then you add 3 and you divide by the input. Okay. Cleaning this up a little bit, obviously this just becomes x squared plus 3 over negative x. Okay. And again, keep in mind, you can move that negative next to the whole fraction. Okay. So again, we have f of negative x. We were given this. These two are not equal because of that negative sign on the outside. Okay. So then the other option is it the opposite? So again, we just check here. Is it the opposite of what we started with? Well, the opposite of what we started with was the opposite of x squared plus 3 over x, which is in fact the opposite of x squared plus 3 over x. So again, this is the other one you can compare it to. Since these two are equal, then we have an odd function. We change the input from x to opposite x, and we change the output sign. That's an odd function.